big but really easy integral. So this integral over here looks monstrous at first, but it's not really that hard, and this integral is from Advanced Integration Techniques by Zaid Alyafeai. Okay, now let's see how do we solve this integral. So basically, since there's minus log x over here in denominator, what we can do is, if we let this integral either IFA, IFB or IFC, if we differentiate this, then we will get a log x factor which can cancel it. Now if the LHS, or let's say RHS, like seems monstrous to you, please know that if we take log, this will just be sum or difference of logs of gamma functions. Yeah. Now our I dash of a, since we are going to have our I dash of a, and this is I, so I dash of a will just be log of gamma derivative, that is digamma. So basically it will not be complicated. We will get some difference or sums of digamma functions, and yeah, the difference in sum of digamma function is really easy to get from the integrals like 1 minus x to the power n by 1 minus x dx. If we have such forms, this is just negative of, sorry, well, Masonic constant per digamma function of n plus 1. So it will not be that tough. So I just gave you an overview of how the integral will be. Now let's solve the problem. First of all, let me let I of a as integral from 0 to 1 minus x to the power a, 1 minus x to the power b, and then 1 minus x to the power c by 1 minus x minus log of x dx. Okay, so now if we differentiate I with respect to a, when it goes inside the integral, it will be a partial derivative with respect to a, so all the other constants x, b and c will be constant. That's why let us write constant as it is first, yeah, because they won't be differentiated. Yeah, and then let's differentiate the remaining thing, that's is this one. Now derivative of 1 is 0, and this is minus x to the power a times ln of x. Now ln of x also cancels out, and the negative sign also cancels out. So we have di by dA is equal to integral from 0 to 1. Now this is x to the power a minus x to the power c plus a minus x to the power b plus a plus x to the power a plus b plus c by 1 minus x dx. Yeah. Now after this we can easily use the integral that it said earlier, this one, 1 minus x to the power n by 1 minus x dx from 0 to 1. We know that this is just nth harmonic number, so that's why this is also equals to Euler-Masonic constant plus digamma of n plus 1. Yeah. Now let us try to use this di by dA. Basically for these we can introduce a 1. Yeah, for this one also we can introduce a 1. Yeah, and for this we will introduce a minus 1. So minus of 1 minus x to the power a, which is basically minus 1 plus x to the power a, so minus 1 will cancel with the other one, and this is also minus of 1 minus x to the power a plus b. Basically the ones will cancel and others will remain as it is, 1 minus x. Now if we distribute it, if we distribute this to each of the expressions over here, we can distribute the 1 minus x to each of them. Yeah, and if we do that, we will get di by dA, this as over here, that will be Euler-Masonic constant plus digamma of c plus a plus 1. Yeah. Over here, Euler-Mastroianni constant plus digamma of a plus b plus 1. Yeah. Over here, Euler-Mastroianni constant plus digamma of a plus 1. Yeah. And over there, Euler-Mastroianni constant plus digamma of a plus b plus c plus 1. Yeah. And now what can we do? Now we can basically cancel the Euler-Mastroianni constants. Yeah. And then we can take dA to other side and then integrate. Yeah. Di equals to digamma of c plus a plus 1 plus digamma of a plus b plus 1 plus digamma of a plus 1, sorry, not plus, this is minus digamma of a plus b plus c plus 1, and over here we have dA. Now let us integrate both. Now we get I, and now the coefficient of a in each of them is just 1, so this is gonna be log of gamma of c plus a plus 1. Yeah, now I think you are beginning to see why that thing was true, like why the RHS wasn't really a scary one. Yeah, a plus b plus 1 minus log of gamma of a plus 1 minus log of gamma of a plus b plus c plus 1. Yeah, and also don't forget the plus c, because plus c is what makes the difference in this problem and in many more as well. Yeah. Now after this, let us try to write them in a single log using the property of logarithms. Yeah, this can be written as gamma of c plus a plus 1. Yeah, and then gamma of a plus b plus 1. Yeah, by gamma of a plus 1 gamma of a plus b plus c plus 1, and then plus c. Okay, now this is the integral. It was a function of a. Yeah, if I remember, this was a function of a. Now, okay, so now what we want, like how do we evaluate the value of c? Yeah, for that what you can do is, if you put x equals to 0, we will have 1 minus 1, that's just 0 dx. So integral of 0 dx is just c, and then from 0 to 1, c minus c is just 0. Yeah, so that's why we can say that I of 0 is actually equal to 0 in this case. Not always though, in this case it's true. So if we use that, I of 0, yeah, we have log of, this will be gamma of c plus 1, this will be gamma of b plus 1, this will be gamma of 1, and then gamma of b plus c plus 1 plus c. Yeah, now this is just 0. Yeah, I of 0 is just 0. Now if we raise all of them to the power of e, we get over here 1, and then we get over here gamma c plus 1 gamma b plus 1 by gamma 1 is just 1, and then gamma b plus c plus 1, and then times e to the power c. Yeah, so now what is e to the power c? Gamma b plus c plus 1 by gamma c plus 1 gamma b plus 1. So what does that imply? That implies that c is actually log of gamma b plus c plus 1 by gamma c plus 1 gamma b plus 1. Yeah, that is it. Now we have the c. Now see, Like C was such a huge expression. Now if you have ignored C, it would have been a great mistake. Now this implies that I, yeah, I is actually equals to I of A or I, yeah, whatever, is actually equals to log of. Now if we put this over here, like it will the inside terms will multiply due to property of logarithms. So we have gamma of A plus C plus 1, yeah, and then we will have gamma of A plus B plus 1, and then gamma of B plus C plus 1, yeah, from here, and then gamma of A plus 1, gamma of C plus 1, gamma of B plus 1, and then gamma of A plus B plus C plus 1. So this is the answer. Yeah, because we have now added the C. Now this is the final answer. Let's check if that's the answer or not. If we check the answer, gamma of A plus B plus 1, gamma of A plus C plus 1, gamma B plus C plus 1, by gamma A plus 1, gamma A plus 1, C plus 1, gamma A plus B plus 1, and under the log. Okay. So that is the answer, and we solve the integral. So basically, this was not in hard integral because after we differentiated, this just like directly went into the form that we wanted for digamma function. Yeah, and then we solve the problem. Basically, these are just some easy manipulations that everyone can do. Hope you enjoyed the problem. Basically, thanks to Zaid Alyafeai, if I pronounced the wrong name wrong. Thanks to him and his book for this problem, and yeah, hope you enjoyed this integral.